In this video, we're learning how to solve radical equations and inequalities. All right, there's a list of steps at the top that you can follow. So you want to isolate the absolute value first. So I'm going to add 4 to both sides. Divide by 2. And now you have to figure out what the index is. In this case, the index is an invisible 2. So the way I get rid of the radical is to raise both sides to the power equal to that index. So in this case, I'm going to square both sides because the index is 2. All right, so that makes the radical go away on the left. We get 4x plus 8 equals 36. So 4x equals 28. X equals 7. And then you're supposed to check your answer. I only check my answer if the index is even. And in this problem, the index is even. And I'm okay with you guys doing this mentally. So if I plug in a 7 there, 4 times 7 is 28. 28 plus 8 is 36. So I'll show a little bit of work. I get 2 rad 36 minus 4 equals 8. 2 times radical 36 is 12. 12 minus 4 equals 8. So this answer works. All right, so with problems that have 2 radicals, you end up having to raise both sides to the power of the index. You have to do that twice. So first, I notice that one of the radicals is already isolated, so I can raise both sides to the power equal to the index. So I'm going to square both sides because there's an index of 2 right there. So doing that to the left side, I get 3x plus 1. Now when I do it to the right side, this is where you have to be careful. This does not equal that. You have to FOIL. So when you FOIL, you get 5x. Then you get minus rad 5x. And then you get minus rad 5x again. So it's actually minus 2 radical 5x. And then the plus 1. All right, so we still have a radical. So now we have to isolate the radical a second time. So if I subtract the 5x to the other side, I get negative 2x. And I can cancel out these ones. So I get negative 2x equals negative 2 times radical 5x. I can divide both sides by negative 2. All right, now I've isolated the radical, and I can raise both sides to the power equal to the index. All right, remember from a previous chapter, you're not supposed to divide by x. Set the equation equal to 0, and then factor. So by the 0 product property, one of these has to equal 0. So either x equals 0 or x minus 5 equals 0. So x could equal 0 or 5. We have to actually check our answers though. So going back to the original problem, if you plug in 0, you end up with 1 equals negative 1. So this solution is actually what is called extraneous. So that's an extraneous solution. It appears to work, but when you check the answer, it does not work. All right, checking 5, I get square root of 16 equals 5 minus 1, and that is true. for number 1, we're going to isolate the radical. So I'm going to do 2 steps at once. I'm going to subtract the 1 and divide by 2 at the same time. So I end up with 7 over there. And now the index is 2, so I can square both sides. All right, check your answer. If you plug in 15, this whole thing equals 49. Square root of 49 is 7. 2 times 7 plus 1, that does equal 15. All right, isolate the radical. All right, so whenever you have a radical with an even index and you have a negative on the other side, you should be able to tell just by looking at it what the answer is. So I know that a radical can never equal a negative. And let me clarify, a radical with an even index cannot equal a negative. So I already can tell that this is no solution. All right, so let's pretend that I didn't catch that. So what if I didn't notice it was no solution, and then I went on to square both sides? So I square both sides, I get x equals 35. Well, now this shows why you should check your answer. If you plug in 35, you get 8 plus 6 equals 2, and that's not true. So whenever you isolate the radical and you have a negative on the other side of a radical with an even index, you should be able to look at it and already tell what the answer is. All right, radical is already isolated. Square both sides. 12 minus x equals 0. So 12 equals x. Put the variable on the left. And it's pretty easy to just plug that in. You could look at it and tell. If you plug in 12, you get radical 0 equals 0. And that is true. All right, so notice the variable is not in the radical. So that actually makes the problem easier, I think. All right, I subtracted 3. Now I'm going to divide by. So remember, the goal is actually to get x alone. So I want to divide by 2 and by radical 3. And I can do both of those at the same time. All right, so this would cancel, that would cancel, and I get x equals, these 2's would cancel, leaving a 1 on top. But you're not allowed to leave a radical on the bottom. So if I multiply top and bottom by radical 3, I get radical 3 over 3. And I don't really need to check my answer because the variable is not under the radical. So as long as I don't make any careless mistakes, my answer should work. All right, number 5 has 2 radicals, but it's nice that when you move one of them to the other side, now both radicals are isolated. And if we square both sides, then both radicals go away. All right, so now it's a simple 2-step equation to solve. We get x equals 5. Check your answer. So plugging in 5 right here, I would get radical 21 minus radical 21, and that does equal 0. All right, number 6 is the first one with an odd index. All right, so I add 2 to the other side first. Now I can divide the 4. Now we cube both sides because the index is 3. That gets rid of the radical. We get 2x plus 11 equals 27. Now we're 2 steps away. All right, x equals 8. And again, you don't really have to check your answer when the index is odd, as long as you avoid careless mistakes. All right, for number 7, the radical on the right is already isolated. So we can square both sides now since the index is 2. All right, so squaring the 2, I get 4. And then squaring that radical, I just get x minus 11 without the radical. The radical on the right side cancels. All right, so we end up with x equals 16. Let's plug in our answer. So if I plug in 16 there, I get 2 radical 5 on the left. And if I plug in 16 here, I get radical 20, which is also 2 radical 5. So this answer works. All right, remember that exponent 1/2 means the same thing as square root. So we can square both sides. Remember to FOIL the binomial. All right, looks like we have a quadratic. Move everything to one side. I like to move everything to the side that lets x squared still be positive. So I'm moving everything to the right. All right, so I subtracted 9x on both sides. I added 12 on both sides. And I know this equals 0. That is factorable. All right, so I get 2 answers, x equals 4 and x equals 3. All right, plugging those into the original. All right, so if I plug in here and here, I end up with 36 minus 11 is 25. The square root of that is 5. And 4 plus 1 also equals 5. So 4 works. All right, 27 minus 11 is 16. Square root of that is 4. 4 is the same as 3 plus 1, so both of these work. All right, now we're moving on to inequalities. So the first thing you do for an inequality problem, if the radical has an even index, you need to take the radicand and make sure it's non-negative. So what does non-negative mean? It means that the radicand has to be greater than or equal to 0. So we're kind of ignoring the original problem. We're only looking at the radicand for now. We want that to be non-negative. Right, negative 4 divided by 20 is negative 1/5. All right, so we know that no matter what answer we get, it has to agree with the statement that we have that x is greater than or equal to negative 1/5. All right, so now let's go back to the original problem and solve that. So I'm going to try to isolate the radical. So first I subtract 5 on both sides. Right now I can divide by -1. Doing that flips the inequality around. And now to get rid of the radical with an index of 2, I square both sides. All right, so when you're solving an inequality, your answer is a range. So I'm going to make a number line, and then we're going to test out parts of the number line. All right, so the two answers we got, and sometimes these are called critical values. Our critical values are -1/5 and 3. So when we took the radicand and set it greater than or equal to 0, it said that x had to be greater than or equal to -1/5. So that part we agree with. So I'm going to cross out everything below that because we should agree that x has to be greater than or equal to -1/5. Now, the inequality in red says we have to be less than or equal to 3. And this is the part I like to double check. All right, so the way you check your answer, you have to plug in a value in this area, and then you also have to plug in a value over here just to confirm. All right, so I think an easy value to plug in the middle would be 0. So if we plug in 0, so I'm plugging in 0 for x, I get 5 minus radical 4. So again, I'm plugging in 0 right here. I would get 5 minus square root of 4, which is 2. Is that greater than or equal to -3? Yes, it is. So when I plugged in something in the middle area, it worked. So I'm going to put a check mark there. All right, and then notice that this arrow goes on forever. So sometimes I don't actually plug in a number when it just keeps going forever that way. I just imagine I'm plugging in a giant number like 1,000,000 or 1,000,000,000. So if you plug in a really big number here, you still end up with a pretty big number, even if you take the square root. So it's 5 minus a really big number. Is that going to be greater than -3? It is not. So I know that this area doesn't work. All right, so if you're not comfortable with doing that, plug in a big number like, let's say we plug in 5. So if I plug in 5 right there, and I end up with 5 minus the square root of 104, and you should know that the square root of 104 is bigger than 10. So 5 minus 10 point something, that is not bigger than -3. All right, so we tested our answers, or we tested the regions, and we ended up with just that middle area. So I need to write my final answer. -1/5 is less than or equal to, and this is a closed circle here because of that symbol. So -1/5 is less than or equal to x, which is less than or equal to 3. And this one is a closed circle because that had the line underneath. So this was our region that worked, and here's our answer. All right, so remember, the first thing you do forget about the inequality problem, take the radicand, set it greater than or equal to 0. All right, so we know for sure that our c has to be greater than or equal to 2. All right, now we go back to the original problem and solve that. All right, subtracting 4, we get 3, square both sides. C minus 2 is greater than or equal to 9. So C is greater than or equal to 11. All right, now I'm going to make my number line. The values that we got were 2 and 11. Remember that we always agree with this one. So that area is off limits because we agree that it has to be greater than or equal to 2. This is a closed circle. All right, and now let's figure out if this is telling the truth. So let's test numbers in each area. All right, so between 2 and 11, I think a nice number to plug in would be 6. And the way I came up with 6, I was trying to figure out what could I plug in where if I subtract 2, it's a perfect square. So 6 works. 6 minus 2 is 4. The square root of 4 is 2. 2 plus 4, that is not greater than 7. All right, so when you plug in 6 for C, it does not work. All right, let's plug in something bigger than 11. So again, try to choose a number where if we subtract 2, we still have a perfect square underneath. So, all right, I'm going to cross out this 6. Now let's try plugging in 18. So I'm putting in 18 right there. So 18 minus 2 is 16. Square root of 16 is 4. 4 plus 4 is greater than or equal to 7. All right, so when I plugged in a number out here, it worked. Remember, this is a closed circle. So our solution is, and I already have it written right there, C is greater than or equal to 11. All right, again, for inequality problems with an even index, take the radicand, set it greater than or equal to 0. All right, now let's solve the original problem. All right, I'm going to do 2 steps at once. I'm going to subtract the 6 to get 9, and I'm going to divide by 3 to get 3. So take 15, subtract the 6, that equals 9. 9 divided by 3 is 3. Now square both sides. Now we make our number line. So 1/2 is the smaller number that goes on the left. 5 goes there. We agree with this. So I'm going to cross out that area. All right, and now let's just double check for the red statement. All right, so what would a nice number be that's bigger than 1/2? So I noticed that if I plug in a 1 right here, then I get a nice radicand. So plugging in 1, 2 times 1 is 2. 2 minus 1 is 1. The square root of 1 is 1. Multiply that by 3. 3 plus 6 is less than 15. All right, so plugging in 1, it works. And now I'm going to put my circles. This was a closed circle. This one was an open circle because it came from over here. All right, so now we have to plug in something big. All right, so I mentioned earlier, I like to just pretend I'm plugging in a really big number like 1,000,000. So if you plug in a really big number, you get a big number plus 6. Is a big number plus 6 less than 15? It is not. So this area does not work. All right, so our answer is 1/2 is less than or equal to x, which is less than 5. All right, start with the radicand. Whenever you have an even index, the radicand has to be non-negative. Right, so I solve that. I get x is greater than or equal to -4/3. Now I go back to the original problem. Right, subtract 8, you get -5. Divide by the negative sign. Square both sides. All right, so now we make our number line. All right, so we always agree with the first statement and we double check the second statement. So I'm going to start with the right side. So plug in a really big number. If you plug in a really big number, you get 8 minus a big number. Is that going to be bigger than 3? It will not. All right, so now I think a nice number to plug in the middle would be 0. So if I plug in 0 here, I get 8 minus 2, which is 5, and 5 is bigger than 3. So this area works. I have a closed circle here, and I have a closed circle here because of that. All right, so my answer is -4/3 is less than or equal to x, which is less than or equal to 7. All right, again, start with the radicand. Set that greater than or equal to 0. All right, now we go back to the original inequality. All right, gonna skip a couple steps. Add the 1, you get 6. Divide the 2, you get 3. Square both sides. 5x minus 6 is less than 9. 5x is less than 15. X is less than 3. All right, so now we make our number line. 6/5 is smaller than 3, so that goes on the left. We agree with that statement. All right, so can I use my technique of plugging in a really big number? So if I plug in a really big number, like 1,000,000, I get a big number minus 1. That will not be smaller than 5. All right, what is a nice number I can plug in between 6/5 and 3? Well, 2 is actually a really nice number. So if you plug in 2, 5 times 2 is 10. 10 minus 6 is 4. Square root of 4 is 2. Multiply that by 2. You get 4 minus 1 is less than 5. So if you're having trouble following, actually off to the side, plug in the number, and you'll see that if you plug in 2, you end up with a true statement. All right, so I'm going to put my circles in. This was a closed circle. The number that comes from making the radicand non-negative is always going to be a closed circle. All right, and then the other one just depends on what the original problem had. So the original problem had a less than, so the other one is an open circle. Right, so we have another answer where it's a between answer. 6/5 is less than x, which is less than 3. All right, write small for this one because this one is going to have a lot of work. So we actually have 2 radicands, both of which must be non-negative. So that has to be true. And so does this one. So d has to be bigger or equal to -1/2. It also has to be bigger than 0. Okay, so both of those need to be true, but they're kind of redundant. It's almost like saying, all right, someone has to be older than 20 and also older than 30. Well, one statement would cover both of them. So I will explain that again when we get to the number line, but let's worry about the original problem. All right, so I cannot square both sides just yet because I have 2 radicals on one side. So what I want to do is move one of the radicals to the other side. And I usually prefer to move the simpler radical. All right, so I move the nicer looking radical to the other side. Now I have to square both sides. All right, so I get 2d plus 1 on the left. And I have to FOIL here. So I get 25 minus 5 rad d. And then minus 5 rad d again makes minus 10 rad d. And then negative rad d times negative rad d is plus d. All right, and now we have another radical, so now we have to isolate that other radical. So I subtract d. 2d minus d is d, and I subtract 25. d minus 24 is less than or equal to negative 10 rad d. All right. Now, technically, I'm supposed to divide by negative 10. Because I don't really want the fractions, I'm just going to square both sides now. All right, so squaring d minus 24, I would get d squared minus 24d minus 24d makes minus 48d. 24 squared is 576. All right, and so one thing I noticed is that if radical d is non-negative, then negative 10 radical d is non-positive. So I think I multiplied both sides by a negative, so I think I should flip this around. Now, it doesn't really matter because I'm going to test the regions anyway. So if this is pointing the wrong way, it's not that big of a deal. All right, so when I square that, I get 100 times d. All right, so now I move everything to the left side. All right, we have a quadratic inequality. Remember, to solve a quadratic inequality, you solve the related equation This actually is factorable. 4 times 144 is 576. All right, so I'm going to change it to an equation because, again, to solve a quadratic inequality, you solve the related equation, which is fine because we're going to test the regions anyway. All right, so we need to make a number line. Let's find some room for that. All right, so we had 4 numbers, and this is not drawn to scale. We had -1/2, 0, 4, and 144. All right, so remember that the numbers that came from making the radicands non-negative, those inequalities are always correct. So one of them said bigger than -1/2, so we cross out smaller than -1/2. The other one said bigger than 0, so we cross out smaller than 0. All right, so pretty much this one would have covered both of these. So we really didn't need the -1/2. Because if we're bigger than 0, then we're definitely bigger than -1/2. All right, so now we have to test some regions. All right, I like plugging in the really big number first. So if you plug in a really big number, even if you take the square root, it's still going to be a pretty big number. So big number plus big number, is that smaller than 5? It is not. All right, so now we have to plug something in between 0 and 4. All right, so if I plug in 1, that doesn't give me a nice radical. It's kind of hard to choose a number that will make both radicands nice. All right, so let's just plug in 1, because at least it'll make one of the radicands nice. So if I plug in 1, and I'll show a little work for this one. If I plug in 1, I get radical 3 plus radical 1, which is just 1. Is that less than or equal to 5? All right, so you should know that radical 3 is 1 point something. You don't really need to know how to calculate that exactly. Radical 3 is smaller than radical 4, but it's bigger than 1. So 1 point something plus 1, is that less than 5? Well, 1 point something plus 1 is 2 point something, and that's going to be less than 5. So this inequality works when we plug in something between 0 and 4. And now let's try plugging in something bigger than 4, but not bigger than 144. All right, so if I plug in 9, I see that at least one of the radicals is nice. So if I plug in 9, I get radical 19 plus radical 9 is 3, which is less than or equal to 5. All right, so another thing you can do is you can subtract the 3 to the other side. So if I subtract the 3 to the other side, is radical 19 less than or equal to 2? Well, the square root of 19 is bigger than the square root of 16. So this number is bigger than 4. 4 or 4 point something is not smaller than 2, so this area does not work. All right, so I just need my circles. This was a closed circle. The 4 came from the original problem, which had the line underneath. All right, so we're finally at our answer. 0 is less than or equal to D, which is less than or equal to 4. Okay, last one is not too bad. All right, so first, take the radicand, set it greater than or equal to 0. All right, and then we focus on the original inequality, subtract 8. Right, so earlier I warned you guys, if you see a negative on the other side of a radical with an even index, you should be able to stop there and figure out the answer. All right, so we know that this needs to be non-negative. When is that less than -3? It is never. So I can already tell the answer is no solution. All right, so if you didn't catch that and you ended up scoring both sides, you would still have regions to test, and you would see that none of the regions work. So if you don't see that, you should still be able to get to the no solution. It'll just take you a little longer. Okay, that is it for 6.7.